All right, let's talk about data encapsulation. So encapsulation or abstraction, you know, these are terms meant to refer to packaging something in a way. So the OSI model, in fact, is encapsulation of different requirements at each of these different layers in order to create a communication mechanism or approach between two devices. So now we're going to talk about the data encapsulation itself. So in order for two nodes to communicate, they must be running the same protocol. And what do we mean by protocol? Because again, I've used that term also quite a bit, and I don't know if it's obvious to everybody what we mean by protocol. But a protocol is essentially a set of rules by which two devices will interact or communicate. So let's take a non-technical example of this, right? So let's say you want to renew your driver's license, right? There's a certain protocol you have to follow. You have to go to the DMV, you have to get a ticket, you have to go present your documents to the person behind the desk. They'll verify everything, then you'll pay them, then they'll give you your license, something like that. It's a protocol, it's a set of rules. You have to follow those rules. If you don't follow those rules, you're not going to get your driver's license renewed. When we're talking in a particular language, if we're having a conversation, there's a protocol. I say hello, you say hello. I ask you, how are you? You tell me you're fine. If you tell me you're fine before I ask you how you are, it may or may not make sense, right? So there's a protocol. There's some certain rules that you have to follow. So in network communication, same kind of thing. You have to have the same protocol if two devices are going to be talking to each other. And so each layer is going to communicate with its equivalent layer on the other node. Okay, so it's doing some stuff for the layer below it and doing some stuff with the layer above it. But essentially, layer 6 here is communicating with layer 6 here, layer 5 communicating with layer 5 here, and so on and so forth. All right. So each layer is going to provide services for the layer above. And uses services for the layer below, but at the end of the day, it is communicating with the same layer at the other end. Okay, so here's a good representation of what we're talking about when we talk about data encapsulation. All right, so when a message is sent from one node to the other, it travels down the stack, as you see right now. It travels down the stack of layers on the sending node, right? So where's the sending node on this side? Over here. It travels down the stack, and then passes up the stack on the receiving node. So essentially, it's going down this way, across the physical medium, and then back up, right? At each level, except at the physical layer, the sending node adds a header to the data payload, forming a protocol data unit, or a PDU. All right, and this process is known as data encapsulation. So in a nutshell, what we're saying is that, think about, so this layer, or let's go one step above, this host, this software, a browser, is going to have some information to send to this browser. It wants to say hello. So it just has the word hello, just to say as an example. So it's going to pass the data to the application layer. And all it's going to say is hello. So what the the application layer is going to do, it's going to add a header to that payload. So the payload is what we refer to as the core data that you're sending, okay? So it adds a header, whatever that header is relative to the protocol. It's going to be based on the protocol it's using. So like I said, in some cases it's HTTP, in other cases it's going to be SMTP, but it adds a header based on that particular protocol, and then that data is essentially encapsulated in this PDU, or protocol data unit. Now that data, or that PDU, is sent to the presentation layer, and the presentation layer is going to do whatever it has to do, and then it's going to add a header, and it's going to send it all down, and that those steps continue all the way down, so that you can think about it as like an onion. You have to kind of unwrap each layer of the onion, and then only that layer that understands the corresponding layers communication knows what to do once that onion is peeled. But each layer of the onion has encapsulated its data in a particular format based on the protocol. Okay, so on a typical local network, just as an example, on the sending node, data is generated by an application such as HTTP, which will include its own application header. So at the transport layer, a TCP header is added to the application, to its application data. Then at the network layer, the TCP segment is wrapped in an IP header. Then the IP packet is put onto an Ethernet frame at the data link layer, and then the streams of bits making up that frame are transmitted over the network at the physical layer. Now, when we get to the other side, to the receiving node, it's going to do the reverse, right? It's going to do what you might call de-encapsulation. All right, so it's going to receive that stream of bits that came in through the physical layer. Okay, so it'll then decode it into an Ethernet frame. From that Ethernet frame, it can extract the IP packet. From that IP packet, it can extract the TCP component, okay, and the application headers, and then eventually you're going to get the data that's required for processing by the software on the other side, which let's say is a browser as well. Okay, so again, just to summarize, the user information is covered or is converted to data for transmission on the network. The data is converted into segments, and then you have a reliable connection set up between the transmitting and receiving host, and that's by what? By the layer 5 session layer. Okay, the segments are converted to packets, and then you get the logical address placed in the header, so each packet can be routed through the network. And then packets are converted to frames for transmission on the local network, and the IP addresses are used to uniquely identify the hosts on the local network segment. Okay, and then the frames themselves are converted to bits, and then you have digital encoding that will convert it to ones and zeros and send it on the physical layer. Okay, so there's another kind of picture of the same approach, if you will. Now, okay, yeah, you can see that essentially as you go down on the left side here, you know, the data is being encapsulated. You start with the data here. Okay. Now it's showing it kind of seems like it's going across, but you have to think about it as it going down and then across and then up. So these 3 segments or three layers have the data. And then when you get to the transport layer, you get the segment header. And then here it's converted to a packet, and you get the packet header. Here it's converted to a frame, so you get the frame header, and then it's encoded on the physical layer. So this actually is a better kind of illustration of what we mean by segmentation, right? You have the initial data at these 3 layers, and then these layers down here add these headers to encapsulate the data. And it's these headers that eventually allow the corresponding layers on the other side to be able to decode them. Okay, all right. If your brain is not hurting, I'm surprised. That's a lot. You know, some places you cover this OSI layer in, you know, a month maybe, you know, or a couple of weeks or a week at least. So it's a lot of information. So don't be worried too much if your brain is hurting right now. It will, like I said, with repetition and as you hear it, these ideas in different contexts and different settings, the meaning of each will become more relevant to you and more personal to what you're doing. So just at this point, make sure you have a good sense that, okay, there's 7 layers, maybe what some of these layers do, about the encapsulation, about the fact that these layers communicate with each other at the same layer. And just review the deck when you get a chance, and if there are any burning questions, we can address them.